For our second video here of the summary of Unit 1, we're going to mess around with some physics. Again, the point of this is not to cover all of Unit 1, but essentially give you a nice quick overview and quick review if you've already looked through the material. Unless you really know what you're doing, I would stick with the Unity tutorials and stepping through them piece by piece by piece. Okay, so what we're going to do is add some obstacles. So I'm going to go ahead and drag in a few little obstacles here, and then we're going to run. And you'll see that's exactly what I was hoping was going to happen. It's a brick wall. So any of these are completely immovable objects. Okay, so this gives us a nice little talk about what corresponds to what in Unity. So each of these has a collider. A collider corresponds to picture a mesh that automatically can kind of detect whether this interacts with another game object. So when we are running, this is detecting that our car hits this object, and since this object does not have a rigid body, it is static. So this does not move. This object stays no matter what. So this is essentially the same as making a giant wall. In fact, you'd go crazy and actually make this sort of a giant wall if you actually wanted to. And that's not a bad idea for later on, that you kind of have these objects sitting right here that can nicely lay out a barrier if you need them. So I'm going to just take that back to its regular size. So each of these is going to need to have a rigid body component. Now this already had a rigid body component. If it didn't, let's go ahead and get rid of its rigid body component. Then you'll see it just drives through everything. So it can just do whatever it wants. So everybody essentially needs to have a rigid body component. So I'm going to just undo, put the rigid body back in here. So here, mass is going to matter. So I'm going to give this a rigid body. Let's give it a mass of, how about 100? And we'll give this a rigid body. Let's make it a mass of 1. We'll give this a rigid body. And let's give it a mass of 1,000. How about 10,000? That'll be fun. So we'll run, and you'll see we ran into that one. It did tip over, but I'm having some trouble moving it. This one moves nicely. This one really barely moves when I hit it. Looks like I'm driving the side. And this one is kind of moving. You see, I figuratively and literally got the ball rolling here. Now the mass of my car right now is just 10. So if I up that mass, then you'll see, let's up our speed a little too here. Let's go 16 on that. It's going to go nice and quick. You'll see, and now it's pretty easy. So rigid body is what's really going to define our physics interactions. Now most of the physics interactions are automatic here. So right now, I kind of don't like I much prefer my camera following, but whatever. So most of our interactions are automatic. We don't actually need to mess around a whole lot except for balancing out masses and whatnot, just to make sure everything's behaving how we want to behave. There is an alternative, though, and I'm going to show you that real quick. You can stop here if you're all satisfied with that. I'm going to show you how to move according to physics. And I don't necessarily think this is the best thing to do. In fact, this actually gets a little messy, but I figured it's a good thing to show you real quick. Okay, so we're going to go back to our scripts. And we're going to go to move blue car, and we are going to change these. So I'm going to comment those out. Comment it's a double slash. And what we're going to do is modify our rigid body instead. Now in order to do that, we need our rigid body. So we're going to need to make private variable, and it's going to be a rigid body, and I'm going to call RB for rigid body. Now here in our start, we have to get the rigid body. So we are going to get the component that is the rigid body corresponding to our object. So this says there is something called rigid body. This says when the game starts, go and get the component called rigid body. So if I look at my vehicle, there's a component right here called rigid body. It's going to go and get that. So get the rigid body component. Then do what with it? Apply some physics. So we're going to do RB dot, and if you look in here, you'll see right there we got a move position. We got add force, and this is for the most part what we're going to use. Now, move position exactly what we had here in terms of translate. Instead, we're going to add a force. Now I'm going to copy and paste. And this is not going to be right because force is going to depend on our mass for the most part. So we are going to have to sort of worry about mass. So in here, we now need to add what type of force, and you'll see it gives us a little hint here, force mode. So we're going to type force mode dot, and we're going to pick a mode. And again, you'll see it gives us some hints here. So force is going to account for mass, velocity change is not going to account for mass. Let's just stick with force the first time, just to sort of see how that works. And then we'll do RB dot add torque. Torque is, of course, a rotational force, so we're adding a force. That's essentially the same as saying rotate, right? We're going to add a rotational force rather than a directional force. And I guarantee you those are really wrong in terms of how this is going to work, but again, we'll get an idea for, there you go. So I am actually hitting the W key here, and you'll see here these values are changing a little bit, but the problem is that this simply is not big enough to actually do anything. So we're going to make this a little bigger. About 400. And let's see. It's going up, but again, it ain't going up by much. So let's go one more. About a 4,000. And it's still creeping along. So I think it moved a teeny bit. Let's go one more. 40,000. And again, you'll see it creeping along there. And then it flipped over. So, welcome to using forces, right? So what we're at 10,000s. So this herein lies the problem with using forces. So weird stuff is going to happen. I'm going to get sort of a weird initial acceleration sometimes, and it's not necessarily going to be pretty, and we're going to have to modify this according to our mass. So I will show you that here. If I use velocity instead, it is a little friendlier. Impulse is weird. That's like when you give something a kick in the pants, but you really don't want to do that. And it looks like maybe 10,000, a little much for velocity. So let's try 100. That might still be a little much. So it looks like maybe that's not quite enough. it's a fun balancing act here. So let's try 2,000. Nope, I didn't want to do 2,000. Oh well. Yeah, 2,000 is way too much. I want to do 200. Still too much. Maybe I was off one of those. 50. Again, this is part of what you just got to deal with. I think what's happening here is I got stuck. So I move forward, and you'll notice that weird shovel in front. That unfortunately makes it so you tend to get stuck on stuff. So I'm going to change this rotational speed up to about 50. And I think, again, I got a little stuck here. So that ends up being actually a big issue. This collider really ends up running into the ground essentially and getting stuck. So that's one of the reasons this physics doesn't necessarily work out so well. Let me show you just a quick little fix for that. Let's say I want to get rid of that. What I do is go to the vehicle. I'm going to copy and paste. So I just did Control C, Control V, and then I'll double click this. I'm going to call this, how about my new car? How about my blue car? And I'm just going to get rid of that front angle. And I'm going to save it. So you'll see my blue car here, and then I'll go back here. I'll move this, and we will go ahead and associate the script with it. And rigid body. Yeah, it's not going to let me copy the rigid body. That's easy to fix though. I'll do rigid body. And then I'm going to get rid of that one. So let's see. That's a little better. Still doesn't seem to want to do a whole lot. So let's go about 100 there. Again, I think the problem is it's basically getting stuck. It seemed a little happier there. We can go up a little and fall. See if it gets stuck when it falls. That seems a little better. Okay. Well, there's at least a way to use physics. Again, I wouldn't necessarily use this. I would probably stick with just doing your transforms for now. The only time I would really worry about making exactly pure physics is if your whatever particular game really needs it. Simulating physics by just changing positions is pretty fine. Oh, that was fun. Wow, let's try that again. The speed was high. Aw, went through it that time. There we go. That's pretty interesting. Alright, so again, long story short, if you want something to interact with your object, make sure you're using a rigid body. If you want to be nice and static and not move, have a collider but not a rigid body. You can edit colliders, by the way. If you don't want to collide with the whole thing, you can do what's called a box collider, so you can get rid of this mesh collider. Sorry, wrong object. So let's go to, say, that cone. So if you go to the cone, you'll see it has a mesh collider, or a mesh collider. You can get rid of that, and you can instead include, say, a box collider. And this box collider you can then edit and sort of make wherever you want. So let's say I want the car to drive a little bit into it. I don't know why you would necessarily want to do that. But if I want to sort of edit the actual collision region, I can. And I think you'll see if we do that, it might fall a little first. Yeah, see, it's sort of sunk into the ground because gravity makes it fall. I have no idea where our car just went. Okay, that really should get you through most of Unit 1. There's already a video up there sort of talking about edits to the challenge.